Okay, so to compute the mean, you just add the numbers up and divide by the number of them. We're going to be computing the sample mean. The symbol is x bar, and that's equal to the sum of the x sub i's minus the number of them. Okay. So adding those numbers up, I get a sum of 35. That uppercase sigma right there just means add them up. I equal 1 to n on there if you want every time, but you just add them up, 35, divide by the number of them, and that's 7. I'm going to go ahead and do it for y as well, except for now it's going to be y bar. The bar just means take the mean of the y's, and this is the sample mean for y. So just add up the y's. That's supposed to be a y. And let's see, that was 55. Divided by 5 is equal to 11. Standard deviations. Okay. First step is to get the deviations, or the differences, between each value of x and the mean. So I'm going to make a column here that's x sub I minus x bar. So I'm just going to take this value 2 and subtract the mean of 7. Okay? 2 is 5 units below the mean. And then now I'm just going to keep on going there. So each one of these numbers is whatever the number is minus 7, minus the mean for that. And I called those deviations. That's just this column of numbers. And you were asking earlier, is it just the average? Well, if you took the average of the deviations, it would be 0 every time. So you could either take the absolute value or you can square the values. There is an application where absolute values works pretty well. But because of the mathematical properties and some things that we'll do throughout the course, to make all of these positive, we'll square each of these values. So now I'm going to have a column that's x sub I minus x bar squared, or the squared deviations. Okay? So these are squared deviations. And when I added those up this morning, in fact, that's 50. So this will be called the sum of squared deviations. So I have deviations in this one, squared deviations, and the sum of squared deviations. So the formula for this is going to be S, or the S of the x's, the sample standard deviation for the x's. So if you're just computing one standard deviation in a problem, you'll see sometimes you just leave the x off. Okay? There are some advantages to putting it on there, though. So it's equal to the square root of the sum of the x sub I minus x bar squared divided by n minus 1. So we'll take the square root now of 50. N is the sample size, the number of them. There are 5 numbers there. And so that'll be 4. 5 minus 1. And that all comes out to be 3.54. While I'm here, we will later on do the variance. Most of the applications that we have until either the next to last or the last week of class will be with standard deviations. But there is something called variance, and it's just the square of this, or don't take the square root. So S squared for the x's, the variance, is just equal to the sum of the x of I minus x bar squared over n minus 1. Don't take the square root. So it'll just be 50 divided by 4, or 12.5. Okay, for the y's, I'm going to do the same thing, just for y instead of x. So to get the deviations for the y's, I'm going to take each y and subtract the mean. So subtracting 11. And I always, personally, add those up and to make sure it's 0. So I'm going to square these. And sum those, 94. And then to get the standard deviation for the y's, I'm going to take the square root of the sum of squared deviations divided by n minus 1, or the square root of 94 divided by 4, and that's equal to 4.85. If I were computing the variance, I just wouldn't take the square root, 23.5.